Okay, welcome everyone. My name is Josh McDaniel. I work with the Wildland Fire Lessons Learned Center. I think you're going to find the presentation very interesting today. Eric Gdula is going to be talking about how Grand Canyon National Park has been using the monitoring trends in burn severity project data there at the park. And I'll let him explain a little bit more about that in just a minute. Before I introduce the speaker, though, I want to make a few announcements. This webinar is part of an ongoing series of webinars sponsored by the Joint Fire Science Program, the International Association of Wildland Fire, and the Wildland Fire Lessons Learned Center. I put some links up on the site, and I want to invite you to check them out whenever you get a chance. There's a growing set of resources all three of these organizations are producing, and there's some really valuable and interesting information available on all three of those sites. Okay, so first I will tell you a little bit about the upcoming webinars. Right now there are two scheduled. Coming up in July, on July 12th, Alan Ager will be talking about a fuel treatment program that he's been working on called the Landscape Treatment Designer. And then in October, it's a little far out, but Stacy Drury will be talking about another fuel treatment decision support system called IFT-DSS. There will likely be other webinars scheduled in between those two, but those are the two that we have confirmed right now. Okay, so to register for any of those webinars, you can go to the Advances in Fire Practice webpage, and the link for that is there at the bottom. If you don't want to type that in, just Google Advances in Fire Practice, or from the Wildland Fire Lessons Learned Center menu, you can navigate to it. It's one of the menu buttons on the left there. Okay, so on to today's webinar. I'll introduce the speaker in a second, but first I just want to explain how questions work. Depending on what platform you have, you should have a box that says questions or chat. You can use that to type in questions, and I encourage you to do that as early as you can to get at the top of the list for getting your question answered. But we won't answer those until the end of the presentation. So once Eric is done with the presentation, we'll start a question and answer period. We'll read the questions out, and Eric will respond. Also, the webinar is being recorded and will be available on the Advances in Fire Practice webpage, that same link that's on the screen there now. And you can pass that link on to anyone you think might like to view the webinar, and it'll be there, I guess, for as long as the internet's there. So, and also we have an archive of all previous webinars that Frames is hosting for us, and so there's a growing collection of webinars on the archive page. Okay, real quick, if you are a member of a group watching this, so if there's one registration and there's more than one person in your party watching it, maybe in a conference room or just a group of people gathered around a screen, could you type that into your questions or chat and just let us know that so we can get an accurate count of how many people are attending? Just at any time you can, that'd be great. All right, so I'll go ahead and introduce the speaker. Eric Gdula is the Fire GIS Specialist at Grand Canyon National Park. He's worked at Grand Canyon for the past 11 years. His previous work includes being the GIS coordinator for the Southeast Group of Parks for Arches, Canyonlands, and Natural Bridges, as well as being the GIS Specialist at Isle Royale National Park. A portion of Eric's current work includes burn severity mapping. He's developed some techniques at Grand Canyon that have led to customizing the monitoring trends in burn severity data, which results in very accurate maps. These maps have been used in a number of applications, which he'll discuss in the presentation. All right, with that, I will hand it over to Eric.
Okay, am I here?
Yep, the screen's not up yet, but
okay.
Yeah.
Should be coming up.
There we go.
Okay. Okay, well, thanks, Josh. Yeah, I just want to point out again that I'm a National Park Service employee. I don't work for the MTBS program or the RSAC program. Truthfully, I'm probably not smart enough to work for those guys. I'm just a GIS guy, and the stuff I'm going to show you is pretty doable by any average GIS person. So yeah, with that, let's get started. So I work at Grand Canyon, as I said. Grand Canyon is in the southern Colorado Plateau. It's a fire-prone ecosystem, and we get a lot of fires here at the park, a lot of lightning fires, and a lot of prescribed fires we do. Here's a slide of just the fire history since 1980 to 2011. Let's see, we average, well, since 1980, we've had over 180,000 acres of fire. And in the past 10 years, we average about 11,200 acres per year of fire on the ground. And we have all sorts of fires. You can see on this map, the colors indicate the different types. We have, well, we used to have wildland fire use fires. Now we have wildfires. We do prescribed fire and suppression fire. And with all those fires, since 2000, we've been doing burn severity on all of those. And here's a image of all the fires on the north rim and south rim that we've done severity on. So what you're looking at here is we've done 47 fires that we've done burn severity on, and that's for 106,000 acres of fire. So we've done a fair amount of burn severity here in the park. The one thing I've learned from doing all this burn severity is that the MTBS data is really accurate and it's really great as it's delivered. But that said, I think you can really improve the data and really tailor it to your specific site by using what are called composite burn index plots, or CBI plots. And what CBI plots do is they give you a field reason why you can re-threshold the data. And if that doesn't make sense, we just re-split or remake where the cutoffs are for the various severity classes, and those are based on the field visits. So that's my plug to go out and put in CBI plots and don't take the data just straight as it is. As it is, it's very good, but again, you can really tailor it, and then you'll have confidence to do some of the examples of some of the stuff I want to show you here in just a few minutes. And the other thing I really like about the CBI plots is it really gives you a good idea of what your fire did, and then you'll have really good on-the-ground knowledge of, hey, that fire burned 100% of the area, or, ooh, that fire only burned half of the area. And you just get that, and they're very easy to put in. And if you want more information on that, I have a slide at the end that'll point you to where you can get that. Okay, so with that, what do I want to talk about today? I'm going to talk about 5 main things here. I just want to give examples of how we've used the burn severity data. And I want to show you how we've used it in pre-planning for fire, how we've used it at the inception of events or right at the start of a fire, how we use it during protracted fire events. So I want to give a couple examples of post-fire assessments, and then I also want to talk about some research we're using data for here at Grand Canyon. So with that, let's start with pre-fire planning. This slide, I like this slide. This was a prescribed fire we did back in October of 2007, and it was a Southwest Roost fire. And we were going to burn the area, I imagine you can see my cursor, we were going to burn the area in the middle here. And part of a prescribed fire is we like to have control line around the whole fire. Well, the question was brought up, could we use the severity data and have enough confidence on the north side of the fire to not put control line in here, and would that previous fire keep that fire within the boundary we want to burn? So we went ahead and used the burn severity data and looked at that and felt comfortable that yes, that would in fact not allow fire to move through it. So essentially all we did was we put line down on the far east side of the fire, right over here, and then we went ahead and we did burn this, and we burned off the ridge tops here, and then a couple days later we went ahead and burned these ridge tops, and that fire went ahead and progressed, and it burned as we expected. It burned into the old fire from 2003, which at that time was only 4 years old, and there was enough solid black there to hold it. Now, why I like that analysis is for a couple of reasons. First, it really improves the safety of all involved in a fire. You don't have to expose firefighters to putting in all this control line along the north edge of the boundary. You don't have to expose those firefighters to falling trees and to digging line. The second reason I really like it is it reduces the impacts to both cultural and natural resources. So again, there's no felling of trees up there. You just don't have to put people out there. And then the last thing that's really beneficial is it really reduced cost. We don't have that extra cost associated with putting in, I think that was about 2.5 to 3 miles of hand line that we would have had to put in. So it's kind of a great, kind of a pre-planning tool that you can look at and if you have good solid data. Okay, so here's a picture. This is, I'm going to give you a couple, or just one example of how we use the burn severity at the inception of fires. And this is kind of a cool slide. One of our fire staff here shot this last year. It's a picture of a lightning strike on the lower fire that started last year. So then whenever we have a start, there's always a discussion of how are we going to manage this fire. Are we going to suppress it right away? Are we going to suppress half of the fire and let half of it burn? Or are we going to let the fire run its course and be a wildland fire use fire, which is no longer a current term. But yeah, so part of those discussions we have when we do that is where's that fire going to go and where can we hold it? And this fire right here, I have a slide up here, started in 2009, and it started right at this little fire in the center. And the concern on this fire was we did not want this fire to burn north. This direction is north. We did not want the fire to burn up through this area in the park called the Neck. And we had concerns about that, but it was burning in an area that we like to let fires burn, and it was a good contender to be a fire use. And in the northern part of the burn, this Neck area, we felt we had enough solid black, again, based on the burn severity data, that this fire that started in 2009 would not be able to go through and push through that area. The other thing we looked at was this area was going to burn in a second entry piece of land that had burned in 2001. And we had the burn severity data from that going, had all burned in low, moderate, and high severity. So there was not a lot of unburned fuels that this fire was going to push through. So we went ahead and we did let that fire burn. And then you can see this teal color that I have up on the screen was the final perimeter of that fire. It was a successful fire, and again, it was able to let burn in part because we had this severity data and we had confidence that the fire would get into that black up on the north end and would not burn through that. Okay. So during protracted events, and what these are, we have many uses we use the severity data for during protracted fire events. And those are fires that were formerly fire use fires, but one of the things we do is we put them on, I'll put them on maps for the division supervisors so they can use them for holding ideas. They look at possible safety areas of places that have burned out. But here's a great example. I really like this one. This was a fire we had last year. And this was a picture of that slide with the tree that was a lightning start. And this was the lower fire from 2011. And this fire started in the park. And here's the park boundary, this kind of salmon color that runs. And this was a good candidate to let this fire burn. It was burning in first entry Ponderosa pine, and it was bringing great effects. When the fire was burning, though, we figured the fire was going to burn and back down into the forest and burn across the boundary. The Forest Service was very willing to allow that to happen, and we managed this fire as a multi-agency fire. Now, what's interesting is the Forest Service has a slightly different outlook on how they wanted to manage this fire, and they wanted to reduce exposure to the firefighters and limit the time that this fire was going to burn. So when it got onto the forest, they really wanted to kind of burn out they subdivided the fire into these blocks, and they wanted to burn these blocks out fairly quickly. And again, it's a safety issue. They wanted to limit the exposure and limit the types of effects they were going to get. The park was fine with letting that fire run its course, and if it ran over 30 days, that was fine. We feel we could mitigate that, any exposure and any risks, and we also feel that we get better effects. We get a mixed mosaic of effects from letting this fire burn for a long period of time, where again the forest wanted to burn it and be done with it. So with that kind of, those two different philosophies on how to manage this fire, we agreed that we would let this fire burn, and then when it came down, the forest went ahead and initiated burning this block out, and then a day later they burned this block out, and then a day later they burned this block out. And all this block 3 is all pinyon juniper, and the fire pretty much ran its own course and just ran out of fuels and burned out naturally out here. But now what's interesting, the use of this, when the forest did the prescribed burning, they lit off of the forest boundary. We didn't want to burn in the park with the prescribed fire technique. So the question was, do we need to put line on the park boundary to hold that fire in the forest? And again, we pulled the burn severity data out, and we had a fire there in 2009 and one on the other side in 2010. And again, using the severity data, we felt we had solid black that we would not have to put line in anywhere along this park boundary. We thought that we had enough black that it would hold. And here again, we have all those cost savings, we have safety savings, and then we have very limited resource damage. So we went ahead and did that, and it was successful. The fire crept a little bit into the park, but never got up any head of steam and just pretty much died at the fence all the way. And this fire wound up burning about 2,000 acres when it was all said and done. And I think in the park it burned pretty much all of this. And the fire ran, I believe it was about 30 days the fire went for. And it just went on. And again, we got great effects from that fire. But just a different way to do business, but a kind of a neat application of the burn severity data. Okay, here's another example of using the data during a protracted fire. And what this was is, this was this was the point fire from last year. And this was an interesting fire. This started 4th of July last year, and it was in, this was all ponderosa pine here. I have a new veg map up in this area, and all this green is ponderosa pine forest. And this happened to be second entry fire. This whole area burned in 2001, and we knew this fire was going to burn and probably burn this whole plateau because the previous fire had done the exact same thing, and the fuels were ready for that fire to burn. Well, the question came up, if this fire kept burning, how far did we feel comfortable allowing this fire to go? When you get up into this kind of orange color, this is a transition area where you have ponderosa pine, but you also have a lot of white fir encroachment. And the question is, if it got established in here, could it get established up in here, which is mixed conifer and spruce fir forest? The issue with it getting established up in this part is a lot of this is restricted Mexican spotted owl habitat, and we have to be very careful with the amount of high severity we put in that area. And I'll talk a little bit more about that in a few slides down the road. But so the question was raised, okay, if this ran up here, what kind of fire behavior could we expect, and then what kind of effects could we expect? So looking at, these were the fires we had done, just a second here. These are the fires that we had done burn severity on in the past. And as you can see, the tower fire from '01 burned great. It had all this low and moderate low severity. We had great effects. But again, the question was, if it got established here, across the road, and then what would happen up here? And then the question was raised, this is all now aspen up here. This used to be mixed conifer forest, but all this red and orange is now aspen. And the question was, could we figure out what kind of conditions may have led to this kind of fire behavior that produced this kind of severity? So myself and the fire ecologist sat down and we looked at this, and the fire ecologist is Wendy Bunn. And we looked at this and we said, we think we probably could do something to figure out what caused this. So what we did was we looked at, let's see, the slide will come up, there we go. We looked at 4 fires that were in similar vegetation type. And here's the fire that started that we were managing. And then we looked at these 4 fires and we thought, yes, we surely could do something with this. So we enlisted the help of the park's vegetation mapping coordinator, Dr. Michael Kearsley, and the 3 of us worked on this project where we looked at what conditions cause these types of high severity fires. So what we did was we chose these 4 fires because, number 1, they were in the same vegetation type. Number 2, they were protracted fire events, so they spanned a whole bunch of different weathers, scenarios, and a whole bunch of different days. And then number 3, because they were protracted events, they had multiple fire perimeters. So we had a number of fire perimeters for every one of these. So what we did then, we did the analysis for all these fires, but I'm just going to zoom in on one fire here, the poplar fire within the park. So what we did is we looked at the burn severity data first. And then what I did with the burn severity data is I reclassified it to just 2 classes, unburned and low severity, and then high severity. Because all we were interested in was figuring out what was causing these high severity events. And then what we did was we looked at the progressions, the daily progressions. And what's interesting about this is there's 2 ways you can store progressions. You can store them as the entire fire. So if you clicked on, like this guy right here, it would tell you, oh, at this point in time the fire is 5,000 acres. Or you can store the data and just so you look at this daily addition to the fire. And that's what we did. We were only interested in how much did that fire grow on that specific day. And there's a reason for that, and it's coming up here. And then what we did is we intersected the severity data with the daily growth data. And the idea was, could we figure out which days had high severity, large areas of high severity, and then on those days, could we go in and look at certain variables and try and figure out, was it weather related, was it fuels related, etc. So what we did was we grouped the data, or we clustered the data into 3 sizes. We did small, which was less than 95 acres, medium-sized patch, which was 95 to 250 acres, and then large patches, which were greater than 250 acres. And the idea was, could we figure out, was there something going on that was causing these large, greater than 250 acre patches of high severity? So what we came up with was this chart, and we found out that when the ERC values get to 65, it's possible that you're going to get patches of high severity. However, when the ERC reaches 80 or higher, it's likely that you're going to generate these high patches of high severity, or these large patches of high severity. And then we also found that max temperature, when it got to be 77 degrees, it was possible that you were going to get high or large patches. And then when it got to 82 degrees or higher, again, it was likely that you would get these high severity big patches. And then finally, we found the minimum RH 19% was a tipping point for it was possible to get those. And then the single digits, 9% and lower, it was pretty likely that you would be generating large patches of high severity. And we realize that all these are interrelated. Obviously, the ERC is driven by max temp and min RH. But this was a quick analysis to answer a management question. It wasn't a great research project that we had lots of time to work on. And we plan on going back to this, and another variable we want to include now is the burn index. We just haven't gotten there yet, but I'm hopeful soon we're going to get to this. So then it was decided that the forecast was for higher ERCs, higher max temps, and we were looking at a forecast of single-digit RHs. So the decision was made to not allow this fire to cross this road. We have a road right here. So we went ahead and let this fire burn its course for a number of days, and then when it got close to the road, we decided to start firing off the road so we could hold it at that road. So you can see this fire burned from 4th of July all the way to September 9th, and it was a long, protracted event. And this is what I was talking about, that gives you multiple days of different weather scenarios, and then it produces multiple types of severity within that. So I think overall this fire was a great success, and it demonstrates how you can use the severity data to sort of answer management questions sort of real time. So kind of a neat application. Okay. Let's talk about post-fire uses of MTBS data. A lot of people are familiar with burn severity data for bear teams and looking at the pretty much, you know, bark maps and reseeding and that kind of stuff. We use it for a lot of different stuff post-fire. One of the questions we can answer is, did you burn the fire hot enough? And this question usually doesn't get asked that often, but here's a great example. We had a prescribed fire here right near the village, and you can see the village is at the north side of the map. And this was a second entry fire, and we wanted to burn this in season when we knew we would get a hot fire and get good effects. And we wanted to burn it pre-monsoons, and we had it all arranged to line up, but then the administrative staff said, no, we'd prefer you not to burn it in season. We'd prefer you to burn it late in the fall because, number one, the village is just to the north edge of the fire right here, and also we didn't really have a proper evacuation plan in place should we lose it. So upper management was more confident if we burned it in, say, October. So we did that, and then what happened was when we burned that in October, it was too cool. You can see this map, we had less than half of the area that we burned actually carried fire. In fact, only 48% of it actually burned. So I would actually say that this fire was probably a failure. It was a success in that nobody got hurt and we did burn it, but we really didn't accomplish much by burning this. And I would say 1 year later, the effects of the fire are already gone. So I think what we learned from this, we walk away saying, you know, we'll never burn second or third entry that late in the year. It really needs to happen early season when the fuels are really right for the fire. So that's kind of an interesting way to kind of evaluate what you're doing and reburn at different times. Okay, so this was another post-fire assessment we do here. This will catch up. Part of the fire program here, we have a lot of threatened and endangered species in the park. One of the species we have is Mexican spotted owl, and part of the Mexican spotted owl's habitat is what's called restricted mixed conifer, and it utilizes certain types of mixed conifer forest. And part of our fire management plan only allows us to burn a certain percentage of that restricted mixed conifer in high severity. This was part of a biological opinion with the Fish and Wildlife Service, and the way we track this is we use the MTBS data as our tracking mechanism. So what we do is, at a programmatic level, it's written into our fire management plan that all this black area right here is the restricted mixed conifer, and we're only allowed to burn a certain percentage in high severity. And you can see that I was talking earlier, the point fire was down here. Had that got in here, this was what we were really concerned about. So you can see that's a big chunk we have of that habitat. So that's our way we analyze that. And what's interesting is you can look at it programmatically, or you can also look at it on a fire-by-fire basis. And this was a fire we had a couple years ago, the Aspen fire, where I showed you we debated on the ignition on that one. This was the 3D map I had at the beginning of my talk here. And this was the effects of that fire. And you can see the gray is restricted mixed conifer habitat in the background. And then we went in here and we had, on this fire, we had moderate high. We had 16% of the fire was moderate high. High was only 3.7% of the fire. So it gives you an idea how each fire burns on a fire-by-fire basis. And what's interesting is you can take out previous entries out of this fire, and that's what's been removed out of here. This is a second entry fire that burned in here, and the effects of the first fire have been already accounted for. So kind of an interesting application. Okay, here's another slide. Our veg mapping coordinator who helped us on this project, he's almost finished completing a new veg map for the park. Well, part of the interesting thing on that is the veg map, the imagery for this veg map was taken in 2007 for the slide you're looking at right now. So the interesting thing is, since that imagery was taken, we've burned over 30,000 acres of that area. So instead of having a static map, we would really like to have a current map. And we feel the way to get at that is to use the burn severity data to kind of track that and implement changes. So this year, the veg mapping coordinator is going to go out when we do burn severity, and we're going to start retaking veg plots at the places where we put in the burn severity plots. And the idea is being, we can say, okay, if this forest was ponderosa pine and it burned high severity, now we know that it's this forest type, because they'll be there right on site and they'll rekey it out. And then what we'll be able to do is we'll be able to keep that veg map current instead of a static picture of what the park looked like in 2007. Okay, some research that we're doing here at the park. Yeah, like I said, we've been doing this for 10 years. I have 106,000 acres of fire and about 46 fires we've done this on. So I've often thought there's a lot you could do with this burn severity data in the form of research. So let me just show you one. This is a project we're just starting right now, and I'm working with the park's archaeologist. And this is kind of an interesting idea. And the question came up, there's two types of archaeology sites. There's combustible archaeology sites and there's non-combustible, at least in the terms of fire, how we look at them. And we always focus on combustible archaeology sites during fires, and we provide protection measures for those sites. The non-combustible sites, we've never really done anything with those sites. So our park archaeologists asked the question, are we damaging these non-combustible sites by not doing anything? Or on the flip side, are these areas that have burned multiple times, is the first entry of fire offering some level of protection to a second or higher intensity fire, should that be? Or are we good just by not doing anything? So the idea was we went in and we looked at, I don't remember, I guess we have 1,780 non-combustible sites that we're using in this study. And then what we're doing is we're looking at what conditions they burned under and how many times they burned. So on this screenshot I have right up here, you're looking at 2 arc sites. I have the arrows pointing to them and they're highlighted. And both of these sites burned twice. The one site burned, well, both sites burned in 2001 and then again in 2010. And the idea here is one of these sites burned in low and low, and then, actually I'm sorry, one of these sites burned in moderate, high, and then low, and the other site burned in moderate, low, and then low again. And again, the idea was, did the first fire offer some level of protection to this site? So the preliminary results of this, which are very interesting, and this is a 3-year project and we're just starting it this year, but I was talking to the archaeologist the other day and she gave me the kind of the preliminary what they're finding. And interesting, they're finding that most of these sites show very little damage from fire no matter what the severity was in the first place. So that actually made us feel good that, you know, not spending the money and not prepping these sites is a good thing. But what was interesting was that she found that the sites that were damaged was most of them were damaged due to human impacts, not fire related, but such as parking a vehicle on the site, or maybe they accidentally ran a control line through the site, and again unknowing that the site was there. So that's kind of an interesting site, and that gets back to the whole thing about using the severity data to not have to put in as much control line. I mean, you just never know what happens out there, so we'll just see what happens. But it's kind of an interesting and another good reason to limit how much activity you do out there. Okay, and let's see. Oh yeah, and then the other thing is, like I said, she's finding that the low and the high, the order of the entry isn't really mattering. Most of these sites are not getting fire damage. So again, that was a good find. Okay, another use we're using the severity for in the research side. The park's fire ecologist Wendy Bunn, myself, and Katie Sauerbray, she's an intern here. We're looking at using the severity data to adjust the fuels map. And in the past, we had just kind of taken scientific guesses at how the fires had altered the fuel types in the park. So in the dead of winter, we would sit down and we'd say, okay, if this fuel model was a TL8, and we think, you know, if it had high severity fire, now it's a TL6 or a TL1. But what Katie's going to do is she's going to actually go in and put in plots and use the FMH plots to see, okay, if the fire type, or I mean the fuel type was a TL8 and it experienced a high severity fire, it actually changed to this fuel model 3 to 5 years later, and then 7 to 10 years later it's gone to this fuel model. So it's kind of it'll be a good way to keep our fuels map current as well. So let's see, what else do I have? Okay, another project, we work with NAU, Northern Arizona University, and we did a couple research projects. This one in particular has to do with burn severity and how it's affecting reducing competition. What we did is we looked at, or how it's affecting veg types, and what we did is we looked at the transition area where the ponderosa pine had the white fir, and the question was, are we being effective with one fire going through there and eliminating some of that undergrowth or that encroachment of the white fir, or does it take multiple entries within there to be successful at that? And the results showed that one fire, no matter what the severity was, really wasn't that successful at removing that you needed that second entry fire to come through. Obviously, if you have high severity fire, you can have a complete type change, and that would do that, but that's not our objective. So what you needed, as we found, is the multiple entry fires in there. And another project we worked on was this was with Kari Pabst, and she was she's an MTBS person, and what she did was she looked at using Grand Canyon data and the warm fire data to compare two types or two ways you can go about doing burn severity data. In this world, there's the DMBR methodology, and that's what we use. And then there's another way to do this, which is called the RDMBR, and that's the relative difference normalized burn ratio. And both of them have their advantages, but what Kari did is she looked at which one gives you better effects, or which one best represents what's actually going on the ground in this area. And what she found was that the DMBR methodology that we're using actually gives us better results than the RDMBR. But what she also found too is that putting in the CBI plots, really that combination of the DMBR and the burn severity plots gives you the best product possible. So that was kind of an interesting project. The RDMBR stuff works really great if you have more open canopy, such as pinyon juniper landscapes, or stuff where you don't have, you know, say 80 to 100% crown closure. If you have that wide open, sparsely vegetated stuff, then the RDMBR works better. So it's a little tricky, but it was an interesting project. Okay, and then some uses. This is from the national level. I stole this from the MTBS website, and this is, you know, policymakers use this stuff all the time to see, you know, are these fire policies actually being effective? And then, you know, resource and land managers use it to see, are the fuel and silviculture treatments accomplishing what they're setting out to? And then people are using it for monitoring. And then again, research and academia. There's a lot of possible research things you can do with this data. You can look at effects of climate. You can look at carbon accounting, emission estimates, and then land cover mapping. This is how the land fire program is keeping their fuels data current. And it's sort of the exact same thing we're doing with Katie, only they're applying that at the national level. Okay, and then this at the bottom here is the website I said you could go to if you want to go look at some CBI stuff. But this is some other applications at the national level that other people are doing. You know, so fuels management, again, people are tracking the effectiveness of their fuels treatment. That's sort of what we're doing as well with adjusting our veg map and our fuels map. And then people are using it for fire suppression planning, and that sort of goes with us with the pre-fire planning. You know, a lot of people look at the severity data and say, hey, if this fire is going north and you have a big area of high severity north, there's no need to put in line. Let's just let that fire burn into that and it'll be done. And a lot of people are using it again for post-fire assessments, fire policy, implementation and effectiveness. And then a lot of people are using the data for the ecosystem and landscape level monitoring. What's great about the data is it's 30-meter resolution, so you can look at a larger piece of area, and it's very effective. You know, if you're looking at a whole system, that's where it shines great. Yeah, so it's really good for that. And then again, EIS and NEPA planning, we use that here for the Mexican spotted owl. That was part of our EIS with our fire management plan, but I know people are using it at the national level that way. And again, wildlife and habitat monitoring. Okay, and then what really helps our program is the fire effects crew. They put in a lot of these CBI plots, so I always thank those guys. It's great to have them. And of course, the MTBS program, they're really great. They really are accommodating and help if you call them up and you want to try something different. They're just a great resource as well. So I guess that's it. I was supposed to finish at 1:45, so I'm good.
All right, thanks, Eric.
If you have any questions.
Yeah, so this is Josh Mediano coming back in. So go ahead, and if you have questions, type them in to the questions box down at the bottom, and then we'll read them out, and then Eric can respond. We also, Jennifer Lecker of the MTBS program, we have her online. She's out of the U.S. Forest Service Remote Sensing Applications Center in Salt Lake City. So she's here to answer more general questions about the MTBS program as well. I guess one question that came to me during the presentation, I'm not sure if you have enough data on this, but can you track over time, are you starting to see more high severity fire in some of these forest types where the fuels are really building, or is it something you can see the trends now in terms of more or less high severity fire?
I mean, that is happening, and people are looking into that. We're not specifically doing it in Grand Canyon. Part of that's also a management approach to how you manage these fires. But yeah, I know a lot of people are looking at that, and the general answer is yes, we are getting bigger fires and more frequently bigger fires with higher severity. Right.
And like, you know, with the new programs where you're managing fire for resource benefit and that sort of thing, is this type of data being used in that decision process early on when you get an ignition, when people are are trying to look at an area and say, hey, how much high-severity fire are we going to have in there? Is there a way you can sort of take this data and project for other forest types around previously burned areas?
I mean, I think that's kind of a difficult thing to do. What we're trying to do here is, in our specific area, we're trying to look and say, okay, under these certain conditions, we think you can expect, you know, a high level of high severity fire if the weather gets to this certain stage, or if it's mostly the weather is what drives it. So we're trying to answer that, and on the flip side of that, we're trying to say, you know, the forecast is to be really cool and dry, and this looks like a good contender to go ahead and let burn, because we expect to get, you know, lots of high severity if the weather goes this way, but since that's not the forecast, let's go ahead and let this burn and come through, and we'll have fire through here. And we can feel good about that. We'll have a low severity fire to hopefully prevent in the future, you know, the day when it's in 95 degrees and 5% RH with 40-mile-an-hour winds.
Right, right. Okay. What other, are there other units in the Southwest that are using this program? Are there other forests in the Southwest that are using this as well that you know of? Any of the ones that are sort of on fire right now?
Well, a lot of those guys, and a lot of those guys use immediate, kind of the BEAR team, that assessment. And I should have prefaced, everything we do is 1 year post-fire, and what we're really doing is we're mapping the ecological response to the fire. But yes, all these, when you have these really large fires, everybody goes out and grabs the burn severity data, and that's what drives these BEAR teams for telling them where they're going to reseed and where they're going to have to put water bars and all that stuff. Yeah, so they use it immediately. In fact, most of these fires have people right on site who that's what they specialize in.
Okay. All right, so we got a couple questions.
I got a few questions.
Yeah, I'll go ahead and read those out. Ralph Godfrey asks, what happened with your thresholding over the years? How have you adjusted your information using CBI?
So the answer to that is, and this is my big soapbox, CBI are these composite burn index plots where you go out and you rate on a scale of 0 to 3 the effects of the fire, 0 being no effect, 3 being high severity. And again, you can go look at their website and see the whole CBI program. But what happens is you put these plots in, and then the CBI data sheet will tell you, oh, this is a high severity fire. Now what you wind up doing is you re-threshold the data. So when you get a DMBR image from the program, in theory the numbers can go from negative 2,000 to positive 2,000, and somewhere in there is the cutoff for burned to unburned, and then low to moderate, moderate to high, and high fire. So just say, for example, maybe at the national level, the MTBS program always says, okay, in your fuel type or veg type, we've figured out that a value of 500 and higher always produces high severity on the ground. Well, we may go out and we'll put these CBI plots and we say, no, we actually think that it's closer to about 425 is where the cutoff for high severities on this fire. Or we may go out and we may say, no, we think the cutoff is actually 650. And we found in all the fires, every year it's different and every fire is different. And I'll just put the caveat that we're really picky and we really split hairs, and we argue over values of 1 or 2 numbers, where I think at the national level, when you're mapping 4 or 5 fires a day, they're good with they're within 50 points. And it's just a scale thing. So we really tailor it to our site.
Right. Okay. Another question comes from Carmen Cypress.
Does that make sense?
Yeah. And Ralph, if that didn't, you can respond, and we'll get him to clarify.
Okay.
Next question is from nope, he says thanks, so I think you got it. The next question is from Carmen Seif. Does your data produce similar prediction results to running Behave or other modeling applications? So have you done any comparisons between sort of fire projection modeling and then sort of post?
No, I haven't run those comparisons. I think part of the problem is some of those programs run under one set of weather conditions, where these generally have been over a course of a variety of them. So I'm not sure how you would get that, but no, we haven't made that comparison.
Okay. All right, Eric. Well, that's all the questions that have come in, so I guess we'll go ahead and end it there. If you're interested in passing the link to this webinar on, I'll have the link up on Advances in Fire Practice in probably about an hour. It usually takes about an hour to load it, and it'll be ready there. And just want to thank Sarah. Thanks, very interesting presentation.
Oh, no problem. Good. You're welcome.
All right. Thanks, everybody.